Kylie has an idea for how to calculate 23 times 23. She says 20 times 20 is 400 and 3 times 3 is 9. So 23 times 23 should be 400 plus 9, which is 409. So this is asking, is Kylie's method valid? If not, how could you modify her work to make it correct? It says, don't just start over in a different way. Work with Kylie's idea. Use the large square below, which consists of 23 rows with 23 small squares in each row to help explain your answer. So 23 times 23, I could multiply those and that would find the total number of squares in this array. Of course, that's not an easy thing to do in your head. So I'm assuming that's what Kylie's trying to do, is to find a way to do this in her head. So she's starting with 20 times 20 and saying that's 400, right? And so again, if that's something you have memorized or can calculate easily in your head, it would make sense to try and use that. So what I might do is I might split this array up. And so maybe split up the 23 into 20 and 3. And I'll do that on both my rows and my columns. So I'm going to color code this a little bit. I'm going to split this up into 20 and 3. And then the same thing along the bottom here. Do 20 here and 3 here. And I'm going to go ahead and subdivide my array as well. So I'm going to split up the 3 from the 20 going this way, and then also going this way. So when she does 20 times 20 and gets 400, what she's actually doing is she's finding the area of this large square, right? The largest square, the 20 by 20. So let me shade that here. So this square right here would be 20 squares by 20 squares. And so in my head, I can easily find that that's 400. So there's my 20 by 20 orange square. And then the 3 by 3 square is right here. So that smallest square would be 3 by 3. So what she's doing here is she's saying, okay, 20 times 20 is going to give me 400. And then 3 times 3 is going to give me 9. And so if I just add those together, that should give me the same thing as 23 times 23. And you can see that there's no way that that's correct because she's missing big sections of this, right? So I'm going to color this in blue. You can see that if she just does 20 times 20 is 400 and 3 times 3 is 9, she's missing this blue rectangle here. And that blue rectangle would have 20 rows with 3 squares in each row. And then she's also missing this rectangle here, which would be 3 rows times 20 in each row. So she's missing those 2 blue sections, right? So you can see this is not going to give you the same thing as 23 times 23. So let's see if we can explain that further. So I think the visual is really nice here because it verifies hey, you can see the blue parts that are missing, but let's relate this back to the distributive property and see if we can find a way to kind of make our method work. So just to kind of remind of the distributive property. So we're used to the distributive property where we multiply one factor times 2 things that are being added or subtracted in parentheses. But technically, there's also a version of the distributive property that has one parentheses times another. So let's say, for example, that we're adding a plus b in parentheses, and we're going to multiply that by c plus d in parentheses. This is sometimes referred to as the FOIL method, and this is really just another form of the distributive property though. So if you never called it FOIL, you've probably done this. And so FOIL stands for first, outer, inner, last. So that means we would use the distributive property to distribute every term in the first parentheses times every term in the second, starting with the first term in each parentheses. So I could start with A times C, and then I can go to the outer terms, so A times D, then the inner terms, B times C, and then finally the last terms. So first, outer, inner, last is FOIL. And so this is a version of the distributive property, and I'm just kind of reminding you of this version. So let's see if we can relate this back to Kylie's problem. So she started with 23 times 23, and the first thing we did is we said, well, let's split up the 20 and the 3. So we're kind of rewriting that as 20 plus 3 times 20 plus 3. And so when she said, okay, 20 times 20 is 400, she was really doing the first two terms, right? So she's getting 400. And then when she did 3 times 3, she's doing the last two terms. And so she's getting 3 times 3 is 9. And so the issue is that you're missing the inside and the outside, right? So if I were to do, so 20 times 20 is the first two terms, but then I would do the outer terms, which is 20 times 3, which is this rectangle down here, right? And then if I were to do the inner terms, 3 times 20, that's this top right rectangle. And so that's the part that's missing. So could you do this? It's maybe, I don't know if it's much easier to do in your head. Maybe it is, maybe it isn't. But technically, if we want to work with her idea, we could just say, okay, you just left out those middle parts, the inner and the outer terms. So let's put those back in there, right? So 20 times 3 would be 60, and 3 times 20 would be 60. And so, when she added this, she added the 400 and the 9 together, and she got 409. We would need to add these extra 60s here, right? So you're going to get like the 409 that she got, but then we would need to remember to add in that extra 120. So if we want to use her idea to find a way to do this, it would work. We just have to remember to put in those extra rectangles that we were missing with her method. So this should be 429. I'm sorry, 529.